Unlike these previous examples, velocity is not always constant. However, you can still use rectangles to estimate the area. The answer will not be exact, but you will have an approximation. Let's begin with the following example. Follow along and copy it into your notes. A particle starts at x equals 0 and moves along the x-axis with velocity v of t equals t squared for time t is greater than or equal to 0. Where is the particle at t equals 3? Let's begin the problem by drawing the graph like I have here. You should draw this graph in your notes for reference. A visual always helps to better understand the problem. Just like when we were estimating the derivative at a point, and there were 3 different ways to find it, there are 3 ways to estimate the area. Left sums, right sums, and midpoint sums, but all 3 use rectangles. When using left sums, you do the following. Begin with the smallest x-coordinate, which in this place is 0, and draw your rectangle starting here. Since there's no height at 0, because if you plug 0 into the time, you get 0, then your rectangle has no height, and when you multiply that by its width of 1, you get the area of 0. So then we started our second point, which is on the graph, which is 1, and we start our second rectangle there. The height at this point is 1 because we plug our x-coordinate back into the equation, so then we have 1 times 1, which the area is then 1. Then we move on to our last coordinate, which is 2. And the height here is 4 because we plug our 2 into the v of t equals. So 2 times 2 is 4, and then 4 times the space, which is 1, equals 4. Sorry about that. So then we add them together. So 4 plus 1 plus 0 equals 5. So the left sum estimation for the area between the graph is 5. So the particle is approximately at 5 at t equals 3.